Please subscribe to my channel and hit the bell icon to regularly receive updates about the videos I post.
Today, we're at the beginning of a fourth industrial revolution. Industry 4.0 is about connecting the digital and physical worlds. Today, most manufacturers' key assets are a part of the physical world. The workers, machines, tools, and inventories that drive both the production process and the end product that customers use every day. But emerging technologies allow manufacturers to use data produced by these physical assets to drive insights based on data. These technologies will enable the construction of new solutions to some of the oldest and toughest challenges manufacturers face in growing and operating their businesses.
Let us now try to understand how IoT is being leveraged in manufacturing with a small example.
Let's take a look at how this works for Simon, the plant manager for an aircraft manufacturer. Simon oversees the production of key components for large commercial aircraft, and his top priorities are meeting production deadlines and producing airplane parts safely and efficiently. One of his biggest clients needs to move up their delivery date by 3 months. Simon and his team use the Internet of Things for manufacturing, which will help them deliver earlier than originally planned. An equipment analytics solution identifies problems with equipment health and performance before they happen and prescribes maintenance procedures so Simon's team can avoid equipment failure and downtime, getting maximum effectiveness out of their equipment. To ensure the components are meeting quality standards along the production line, Simon uses a quality analytics tool to identify variability in the manufacturing process in real time. This allows equipment operators to make adjustments to process parameters based on plant conditions that could affect the quality of production. By monitoring quality in real time, Simon's team can avoid producing faulty components, ultimately saving time and money.
Let us now take a step forward and understand how Industry 4.0 or digitalization is impacting the key functions of manufacturing. Typically, the functions shown on the screen, that is production, maintenance, planning, and quality, has felt the most impact in terms of the financial benefits out of this digitalization. Hence, I will very briefly give some pointers on what are those digital interventions that are taking place in different functions of manufacturing, which is production, maintenance, planning, and quality. So, starting with production, most important intervention is to have an integrated view of all the shop floor operations, which impacts throughput and cost. Many people or many companies rather are referring to this as their smart factory solution and also as connected factory solutions. But what it essentially means is having an integrated view of all the shop floor operations. Now, how does it benefit? Having such visibility enables data-driven decision making and eliminates hidden bottlenecks and uncovers hidden capacity. The question is, how is this achieved? This is achieved by integrating various data sources, which are man, machine, material, and method. So sensors or tablets and various other mechanisms are used, which enables real-time flow of this information about all these 4M, man, machine, material, method, and hence you get to know what is their real-time status, and so you can plan your interventions to achieve the benefits in terms of throughput and cost. The second point, which is real-time OE monitoring, is a subset of the smart factory or the connected factory solution that we talked about, but is often being implemented as an independent solution. So in this solution, you have automated recording of all the loss buckets and automated calculation of OE, which is readily available in forms of dashboards and reports. Now, generally, production operators log all their production data in logbooks. So this is an automated solution to eliminate all the manual errors and inefficiencies that are in manual recording of the production data and the loss data and the downtime data, etc., etc. So using this automated monitoring or automated recording of data, the production team gets a clear visibility of the spare capacity, maximum loss buckets, and they can perform various types of analysis to take decisions which can help them reduce the losses and hence improve the OE. So coming to maintenance, there are two major use cases in focus as of today. One is predictive maintenance and the other is repair recommendations. Now, both of these solutions are focused on improving asset reliability and maintenance efficiency. If we talk about predictive maintenance, it's very much popular and more talked about. What it entails is uh, using system or using past historical data, a combination of rather historical data, machine learning models, and different algorithms in order to be able to predict the failures of an asset. So, for example, the system will be able to predict when your motor bearing is going to fail, or when you might have shaft imbalance, and so on. So, for critical assets, you will be able to predict all the failure modes of your critical assets. The second use case, which is repair recommendations, this entails wherein the system is able to generate what are the recommendations in order to perform the repair procedures for some assets. So, for example, in the case of trucks, this solution has been implemented wherein the system continuously reads data from the trucks and is able to predict when an axle is going to fail and how the driver should repair it, and when should the driver repair it. Similar application has also been in use for electric drives, where the system can specifically tell whether a control board has failed or which part of a drive has failed and what is the procedure to repair it. Firstly, firstly to find out which part has failed specifically by the system, and then how to go ahead with the repair. Now, this itself, if you talk about the benefits, it results in asset uptime of ranging from 10 to 15%, and this has also resulted in reduction in maintenance costs, which ranges from 10 to 30%. So, a leading chemical manufacturing company has saved almost 60,000 euros annually from a pilot project only for a single critical pump. So, they are now able to predict the failures and hence include replacement activities in their regular maintenance schedule and thereby reduce downtime. Let's quickly come to the next function, which is planning. So here, the solution that is being talked about is dynamic scheduling. Using real-time production data, inventory data, dynamic scheduling of the production plan is performed. So this makes high-variety, low-volume production runs more economical. So the system can plan the different SKUs in a way that the total number of changeovers are reduced, and hence this has resulted in reduced number of changeovers by 10 to 15%. The next use of digital is in quality, and this can add a significant value. However, the impact of this is often underestimated. The use of technologies like video analytics, statistical analysis, machine learning algorithms now make it possible to more easily analyze the numerous sources of variation and hence predict defects at earlier stages of the manufacturing process. A leading electrical goods manufacturer reduced its cost of quality by 25%, leveraging a solution that prescribes the optimum process parameters to achieve the best quality output. Also, another example is of a leading pharmaceutical company which is now relying on infrared technology to detect counterfeit measures and contaminants without the conventional destructive tests at time speeds, at running speed. You don't need to stop the line in order to be able to predict the defects that is going to happen on the line. So now, having understood the benefits, I'm sure the next question is, how is all this possible? How can it be done? So integration of machine data is one of the most critical steps towards embarking on this digital journey. So I plan to talk about this in detail in my next video. So please subscribe to my channel to get notifications once the video gets posted. Also, if you are interested to know further details about any of the things that we talked about, I understand it was in very brief, but this was just to give an overview of what's happening around in the industry. But do feel free to post your comments if you'd like to understand more about any of these aspects covered in the video and beyond, which is related to digitalization or Industry 4.0. And I will certainly reply to it. And if there are many people having similar interests, I will for sure go ahead and create another video about the same. So thanks for watching. Until next time, bye, take care, and keep learning.